Hi guys, sorry I'm not there today. Like I always say, if I'm not there, I try to advance the material just so we don't get behind or anything. But anyway, yeah, some lovely hands in here. But anyway, I'm going to go over the two, especially for fourth period, the two Hardy-Weinberg equations. I know we went over this a little bit, but I don't think you guys got as much as eighth period just because, you know, they didn't have as many kids, less presentations, you know, they're a little bit ahead. But nevertheless, two big equations for Hardy-Weinberg. First one, P plus Q equals 1. And then the second one is going to be our P squared plus 2PQ plus Q squared, which also equals 1. All right. Now for these two equations, each one serves a different purpose. For our first one, the P plus Q equals 1, the P is our dominant allele. So this whole equation is only going to be for alleles. P will be our, I'm just going to use R as an example. P will be our dominant allele. Q will be our recessive allele. Now over here, these are going to be our genotypes. So anytime a problem gives you something where you're talking about a phenotype or a genotype, anything like that, you're going to start off using this equation. P squared is our homozygous dominant, so in this case, if we're using R, it'd be big R, big R. 2PQ is our heterozygous, which is big R, little r. And Q squared is our homozygous recessive, which is little r, little r. So for you guys, fourth period, I just wanted to go over the last example in your notes. It was Hardy-Weinberg example 3. You guys could look this up on my website, but the problem states cystic fibrosis is a recessive condition that affects about 1 in 2,500 babies. So I'm just going to write that 1 in 2,500 babies, and we know it is recessive. All right. So it affects 1 in 2,500 babies. Calculate the following. So it wants the frequency of the recessive allele, the frequency of the dominant allele, and the percentage of heterozygous individuals. All right. So I'm just gonna, we'll come back to this. Don't worry, it's not gotten too far away. Just kind of right there. There you go. All right. So we got that 1 in 2,500. If we wanted to use this, we could get the percentage or the frequency, either one, out of this by doing 1 divided by 2,500. So when we do that, we get 0.0004. If we wanted to make that into a percent, we just times that number by 100, which would be 0.04%. So not that much. This would be a phenotype. So these are talking about people who have cystic fibrosis. So if this is a phenotype, we know that these alleles, these are alone. We can't use these to show a phenotype. In order to show a phenotype, remember, each trait, no matter what it is in your body, needs to have 2 alleles. They could be homozygous dominant, they could be heterozygous, or they could be homozygous recessive. So if we're talking about cystic fibrosis and we're talking about people who have it, given that it's recessive, we know that we have to be talking about the little r, okay? That's what one that the problem is talking about. So we know little r is going to be 0.004. So let's go with that. Little r, that stands for our Q squared. So that gives us that Q squared equals 0.0004. If we want to solve for Q, we're just going to take the square root of each side. So we're going to take the square root of 0.0004. And when I do that, I get 0.02 for Q. All right, so that's part A right there, guys. That's our answer. The frequency of the recessive allele, that's Q. Remember, these are our alleles. That's Q. That's our recessive allele. So we know the Q is 0.02. All right. Now from here, what we can do is we can calculate our dominant allele, because we know P plus Q equals 1. P plus 0.02 equals 1. And then with that, just subtract 0.02. And we get P is 0.98. All right, so that's part A and that's part B. Part A, Q equals 0.02. Part B, P equals 0.98. All right, so nothing too crazy there. Now for the last part, to find out our percentage of heterozygous individuals. All right, let me go back to the first part here. Okay, which one is our heterozygous? That's this. Okay, that's what we're trying to find here. We know that that is going to be 2PQ. So all we do for that, 2PQ, what was our P? Oh look, there it is, it was 0.98. So we do 0.98. And 0.02 for our Q. And when we multiply it together, we get 0.0392. Now, if you notice with this, it asks for the percentage, it doesn't ask for the frequency, so we got to times this number by 100, and when we do that, we get about 3.9%, or you can round it to 4, either one works. All right, so here was one problem, guys. It gives you pretty much everything you need to do the problem. You just kind of got to finagle things a little bit, like in this, to get our Q. All right, so hopefully this one helped, guys.